I'm here with Dr. Romano to do a problem on alkene rearrangement.
Come on in, let me show you a really good problem that I think you'll enjoy for the DAT. This will be very helpful. What I want to do is to take this molecule here and add HCl. Now, normally you would think, I would just use Markovnikov's rule. The carbon with the most H's gets the H and the other carbon gets the Cl. Well, that would happen, but that would be a minor product. Anytime you see an alkene, and look at my hand, if you take your hand away and you see branching, that's going to signify that there's a very likely possibility you're going to get this rearrangement to occur. Go to the DAT Destroyer and you'll see a problem exactly like this, and I have 2 of them in that book, which shows you you're going to do a Markovnikov addition, but there's going to be a rearrangement. So what we're going to do, if you see a rearrangement on the DAT or you see branching on the DAT, what you're going to do is go off to the side and do a quickie mechanism. The first step, you pick up an H and you form a carbocation. The carbon with the most H's gets the H, and as you can see, you form a carbocation. That's the slow step, or the rate limiting or rate determining step. You then examine the carbocation and check for the stability. This is a secondary, not bad. But if you do a methide shift, notice a hydride shift would give a primary carbocation, but if you did a methide shift, you form a very stable tertiary carbocation. This is where I never see any chemistry books really give kids understanding of this. What could happen here is the Cl- could attack this. And it happens. It does. It'll happen maybe 15% of the time. But instead of having the Cl- attacking, the shift also occurs at the same time. So, Alexandra, who do you think would win? The chloride attacking or the shift? What do you think's faster?
The shift?
Absolutely. The shift is faster. So even though some of the Cl- might hit here, the shift is faster. So that means that we now have a tertiary carbocation in the reaction mixture, and that is what's going to be intercepted by the chloride ion to form this tertiary halide, and I call this, if I number it from left to right, 2-chloro, 2,3-dimethylbutane. I hope that gives you a great understanding on a problem to look out for. Another thing to look out for on the DAT is whenever you dehydrate an alcohol. If you have a primary alcohol, you're going to dehydrate it by an E2 reaction. If you got a secondary or a tertiary, it's going to go by E1. And whenever you do a dehydration by E1, you always want to form the more substituted alkene, which we call the Zaitsev product. So in this example, if you heated this up and mentally you just took off an OH and the H and you put the double bond here, this would be the major product. And if you pulled the H off from here, that would be the minor. Let's investigate the E1 mechanism. The E1 mechanism and the SN1 mechanism share some commonalities, one of which is they share the same rate law. Secondly, they also share the idea that you're going to form, in the slow step, the intermediate carbocation. So what we did is we first protonated the alcohol as usual to transform a poor leaving group into a good leaving group. The water leaves and you form a carbocation. Now, yes, there could be a shift, but I don't even need to do the shift because in this example, the shift really wouldn't do any purpose, because if you do an elimination, and I know it's an elimination here because we have heat, what we're going to do is we're going to pull off an H and we're going to form the more substituted product. Even if you did a shift, you would still end up forming the Zaitsev product, which is the more substituted alkene. So I hope you can see 2 examples where you would need to understand a little bit about the mechanism to be able to predict the product. First, if you see branching, I want you to think shift. Secondly, if you see a secondary or a tertiary alcohol, think E1 and go Zaitsev. All right, I hope this helps on a guaranteed question. If you don't understand anything, hit me up on the Facebook study group page and we will discuss it. Bye-bye.